Hey everyone, what's going on? Welcome to episode 5. I'm Jeff Noble. Episode's all about loops. Episode's all about loops. Stop. We use loops in programming where we need to do things over and over again. Over and over again. Again. Do we have to do this every time? Sometimes when we loop, really? We know how many times we have to repetitively do things. Sometimes we just loop through things until we know that they're done. All right. Sometimes we just loop through things until sometimes, come on. This is the Noble Cause Software Development Course. First off, I want to thank everyone for subscribing to the channel, and I'd also like to thank everyone, especially on Reddit, for giving me some really great feedback. If you have any comments or you want me to address something specifically, please feel free to leave comments either on these videos or contact me through Reddit. I do listen to all of the comments and I try to take criticisms and feedback really seriously. So one of the things that got brought up a couple of times is that some more advanced programmers who still considered themselves beginner to intermediate understood a lot of the things we're covering. They know about variables, they know about conditional statements like ifs and switches, and they understand loops and how to use them, but they don't really understand how to take those concepts and build software with them, right? Make a game, make an app, make a website, make whatever you have your heart set on. So I'm going to use that feedback, and we're going to start to see examples in more real-world software. For this course, at the point we're at, I need at least 3 more episodes, possibly 4, depending on how deep we go into certain subjects. And then we'll probably switch away from these console apps and we'll jump into another project type and actually show how to use some of this stuff to build things that would make more sense contextually. So with that, let's stick with our console stuff for now and jump into the idea of loops. Again, I'm not going to go through this part of project creation. We should know how to do that comfortably by now. I'll call it out as I do it. So create new project, console application. I'm going to name this noblecause.loops, and then I'll create an episode 5 folder, and we will keep it on .NET 5. All right, here we are. So we're going to get rid of our console write line. There's a few different types of loops. In order to discuss them, you have to understand whether or not you know how many times you want to loop. So if we look at episode 4 with arrays, we might have an array with 5 things in it. If we want to print those out, we know we want to loop through it 5 times, right? We can ask the array, what is your length? And that's how many times I want to loop. There are other times where you just say, I want to loop forever until I'm done. So we're going to start with that one, which is called a while loop. A while loop will repeat its body of code until the while expression is false. A while loop looks like this. Everything in between the curly braces of the while repeat as long as whatever's inside the parentheses remains true. So if I had a variable called isDone, and I make it false, if I type while is done, it won't even enter into the while loop because this condition is false. We're going to create a simple number guessing game, and we'll want to repeat the guesses until we get it right. So I'm going to rename isDone. I'm going to hit Control RR, which is a rename symbol, which will rename both of these at the same time. I'm going to type has winner and then hit enter. So we don't have a winner. And then we will play our game here. And then we'll check if there is a winner. And we can flip the variable. Okay, so we have one problem here that this says we're going to go through this loop while we have a winner. That's not what we want to do. We want to stop playing when we have a winner. I actually want the opposite of this, so I have two choices. I can either negate with the exclamation that says while not, the exclamation is a not, while not has winner, so it'll check whatever the value is in this variable and it will flip it. So while I don't have a winner, keep playing. Or I can change this variable to something that starts off true and we mark it false when we have a winner. Something like still playing equals true. And then once we have a winner, we could say still playing. But talking about things in reverse like that doesn't feel natural to me. So I want to play while we don't have a winner. So right now we're just starting to play the game, so we don't have a winner, it's false. The first thing I want to do is I want to define the rules of the game. So this is going to be a simple game where the computer picks a random number between 1 and 100, and you have to try and guess the number. And if you're higher than the number, it'll tell you that, oh, my guess is lower. And if you guess too low, it'll tell you that it's higher. And we'll keep comparing. This is going to use everything that we've learned up to this point. So first, let's get our random number. So we're going to call this winning number. And we're going to have it equal a new random. Now, what new random does is it creates this object, this class random. It creates a new instance of it. So what this does is it creates a new random class, a new instance of the object random, and it seeds random with some calculations based on how many seconds it's been since a certain time, maybe some other timing information from inside of your computer, and it runs that through a complex algorithm to generate a random number. Unfortunately, what we're doing on this line is I'm creating this new random object and storing it in the winning number variable. I want the winning number variable to have a random number, not a random object. So I'm going to add a dot after this, and I'm going to select the next method, which returns a non-negative random integer. If we look through the overloads here, you can see that one of the things we can pass next is our max value. And it will pick a random number between 0 and the max value. So I'm going to put 100 in there, and that will generate our random number. Don't worry too much about this syntax. We haven't covered methods yet. That's actually our very next lesson. Once we go through that lesson and the lesson on objects, for now, just know that doing this line right here creates a random number between 1 and 100 and assigns it to this winning number variable. The first thing we want to do before we enter our loop is to print out the rules of the game. So console.writeLine, and in quotes, I'm thinking of a random number between 1 and 100. Can you guess it? So there's the rules of the game. Then we go into our while loop. We want to ask the user for their guess. So another console.writeLine. Enter your guess and press enter. And then if you remember from the last episode, we talked about readline. We'll get information from the user from the keyboard when they type it and store it in a variable. So we'll just call that variable the guess. And if I could type it correctly, there we go. Needs a capital L. Remember, readline returns only a string, and we're going to be comparing the guess to a random number that is an integer that returns an int. So we need to convert that. So last time I did the int.parse this time I'll do the other one I spoke about, which was convert. So I can type convert.toInt32 and pass the convert.toInt whatever is typed by the user at the prompt. So now I have the user's guess. So the rest of it is just comparing. So I can say if the guess equals the winning number, then we have a winner, right? They guessed it direct on. So I can say console.writeLine, congratulations, you win. The number was, and we can put our number in here. If we add interpolation, we can now put a variable in these curly braces, and we can just have it print out the actual winning number and add our semicolon. And then we want to enter our loop so we don't keep doing this over and over again. So we'll put has winner equals true. And so the while loop will repeat all of this code. It'll continue with the rest of it until it hits this curly brace. And then it'll come back to line 14 where it will evaluate, has winner changed? Is it not true? Which is the same as false. So if has winner is false, then let them guess again. If they guess it right, then we have a winner. So when it comes back up here and has winner is true, is it still false? No. Then it will exit the loop and it will continue with any code here. Make sense? So now let's check the other conditions. So we've checked if there's a winner and we flip the variable if there is. So now let's tell them if they're higher or lower. So if the guess is less than the winning number, then we want to tell the player, nope, not it. Your guess is too low. Right? Because the guess is less than the winning number, so you got to guess higher. So we could have either said your guess is too low or my number is higher. Same difference. All right, I'm just going to copy these 3 lines of code and we'll flip this guy around. So if the guess is greater than the winning number, then we'll say your guess is too high. Let's go ahead and run this. All right, I'm thinking of a random number between 1 and 100. Can you guess it? Enter your guess. We'll just put 5. And nope, not it. Your guess is too low. Now look what it did. Enter your guess and press enter. So we hit the condition here. Nope, it's too low. It then went to the next line of code that said is guess greater than winning number, which it's not, so it won't go in there. It hits the end of the while loop. Has winner still not true? Well, it is still false because the only place we flip it to true is if you win. So it repeats the loop, and it'll do this until you guess the number. So if we want to split it and say 50, now it's too high. So we'll go down by 20. It's still too high. How about 10? Still too high. So we know that we hit 5 and that was too low, and 10 is too high. So it's between 5 and 10. So let's guess 7 is too low, 9, and we win. Congratulations, you win. The number was 9 and the program exited. We can also see this with the debugger if we put a breakpoint on line 14 by clicking in this little gutter and hitting run. Now the code will stop executing at line 14, and we can hover our variable and see has winner is false. It then prints out enter your guess and goes to read line. So we'll put in our new guess just to show you that it's not 9 again. We can look at our winning number in here in code is 73, is the random number that was generated. And our guess is 9, so 9 does not equal the winning number, so therefore it doesn't go in there. Is 9 less than 73? Yes, it is, so it tells you nope, your guess is too low. And then it checks also if guess is greater than. Well, 9 is not greater than 73, so it skips that one, goes back to the while, where it checks has winner changed. Is it still true? Because I only want to keep looping while has winner is false, where it's not true, where it's not has winner. And we'll just keep playing that game until we guess 73, at which point it exits the while loop. Congratulations, you win. So that's one kind of loop. I'm going to open up episode 4's project now on arrays, and we'll use that code as our example for a better way to do this stuff right here. One thing I gave as extra credit, which I'm going to give you the answer for now, is if we captured each of these questions in an array instead of in first answer, second answer, third answer. First thing I'm going to do is make a variable to hold our answers. So answers is going to be an array. And there's 8 elements to our array. If this isn't making sense to you, please watch episode 4 part 1 and episode 4 part 2 card, and that'll make more sense. So now we have our array of answers, and so I can collect answers 0, and I can change the same variable out for each of the answers and just go back and change the indexes. 0, 1, 2, 3, 4, 5, 6, 7. So I've used one variable, and each index of the answers array bucket will hold the answer to the question as we ask. So the user will type in from readline, it gets converted to an integer through parse, and it gets stored in the new index of the array. So to not have to do all this, I'm going to comment that out, Control K, Control C, or you can use these icons up here to group comment and uncomment. Now I'm going to use another kind of loop called a for loop. With a for loop, you define the variable and how it counts. It will repeat everything between the curly braces until the expression that it checks is true. What does that mean? First thing we have to do is create an iterator. So I can just say var I. By the way, I is a very common iterator. It goes way back to the earlier days of programming, so you'll see a lot of for loops with I and j in it. I is going to be equal to 0, so it's an integer. There are 3 parts to a for loop. They are separated with semicolons. So the first part defines the counter, which is going to be I, and I is going to start at 0. If you wanted to count from some other number to a maximum number, then you would start I at a different number here. But since we're going through an array, we want to capture answers 0, answers 1, answers 2. So we'll just want to change the 0, 1, 2, 3, 4, and we're just going to want to count with a loop. So I'm making a variable called I so that I can access those with answers of I, and I will change each time through this loop so we can access these variables one at a time. The next thing that the for loop takes is the expression. How does it know when it's done? Well, we're going to tell it you're done when I is less than answers.length. Remember, answers.length is the length of the whole array. In our case, since we created it with int 8, 0 through 7 makes 8. So what we want to do is we want to keep going with this loop as long as I is less than the length, which is actually 8, because we set our variable up with 8 slots or 8 indexes when we created it. So I starts at 0. When it loops around and comes through again, I will now be 1. Is 1 less than 8? Yes. So it'll keep going. Then it'll go to 2, 3, 4. Once it gets to 7, is 7 less than 8? Yes. And the following time that it goes through, is 8 less than 8? Well, no. 8 is equal to 8, so therefore it would stop looping through the for loop. The last part of a for loop is how many to count by. we're going to use I++ because we want it to increment by 1. We covered I++ in a previous episode. Card. So what we actually want to do is we want to print this out. We want to console.writeLine the favorite movie, but we want to loop through our answers. Instead of using this favorite movie of first answer, we've replaced first answer with our own array. So now it's just going to loop through here, repeating this one line of code, but it's going to replace answers I with whatever the index of I is. So the answer to, in that stupid Christmas song, how many golden rings, the answer is 5. The user will type 5. 5 will get stored in answer 0. The first time through this loop, since I starts at 0, it's going to console.writeLine favorite movie, line 5, because answers of 0 was 5. And favorite movie of 5 will print out this line of gobbledygook, because that's what's stored in line 5. So as long as we answer these correctly, this few lines of code replaces all of this, so you can see how much more efficient it is and how much easier it is to think about once you get used to using arrays. So if we run it in that stupid Christmas song, how many golden rings? 5. Old movie, 3 amigos. How many quarters in a dollar? 4. A misspelled how many teams in a football game? 2. A clear Pepsi product, 7-Up. 5 plus 1 is 6. What number are you if you're first in line? I am number 1 in line. And I am a total 0. Hey, at least I didn't say you. And you can see it still prints out my favorite movie of The Matrix. Okay, the next thing we're going to do is we're going to look at the for each loop. For each is also something you can use when you know how many times you need to loop, just like the for. The for each doesn't cause you to keep track of the indexer. You don't have to create your own variable. You just have to go through the array elements themselves. So in a for each, you'll give a variable to each individual answer in this case, and then you'll give it the list of answers, and it'll go through them one by one. In our example, we would want to create a variable called answer, which is an individual answer within our array of answers. So if answers has 8 things in it, the first one, or answers 0, we want to call that value answer. When we go through our loop and we get to answers 1, then answer will equal this one, and then answer will equal this one, and answer will equal this one until it gets to the end. So we say for each, and we create a new variable called var answer, and we say in answers. For each will take care of going through each of the answers array elements and assigning them to this variable until it gets to the end curly brace and it loops around. If it hasn't gone through all of them, then it'll keep going, but first it'll reassign answer to the next one in the array. So I can repeat this line, but instead of answers 1 in here, I just want to use the current answer. So we're gonna walk through that. First, let's see it work. First in line 0, and it prints out the matrix twice, once for this loop and once for this loop. They look identical because they're doing the same thing. And if we were to debug by putting a breakpoint here and hitting run, 1, 0. And our answers array, if we look at those, are 5, 3, 4. There's our answers as we type them in, stored in each of the answers indexes. But answer itself is set to 5, which is the first one in the array list, right? 5. So the next one's going to be 3. So if we step over, we write the line out, and then it loops. It checks, it assigns the next answer variable. So now that answer is done, it's now 3, not 5 this time. And it'll just continue doing that. If we look at answer after it assigns, now it's 4 until it's done. Let's get rid of that breakpoint and continue. And we get our output. So those are the 3 types of loops that you'll be dealing with: the for loop, the for each loop, and the while loop. Most of the time, you're going to be using a for each loop. A quick recap, we have 3 loops that we learned today: the while loop, the for loop, and the for each loop. The while loop you use when you don't know when you're done. You want to keep going until some condition changes and you know that you're done. For instance, reading a file off of a disk. You can read the file line by line, but you don't really know how many lines are in that file, so you just keep reading them until you hit the end. If you've hit the end, then you're done. There's your while loop case. A for loop is great if you need to iterate through a list, but you need access to that counter. Maybe you want to count by 2s, or you want to use that iterator variable, in our case I, for other things. And last, the for each loop, which is used to loop through something where you don't need access to the iterator, but you do know how many times you want to loop. In our case, we went through an array and we printed out all the values of the array. All right, that's it for this week's lesson. So as always, practice, 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 and let me know if you have any questions in the comments. Please subscribe if you can and you find this interesting, and I'll see you online.